Hello friends, welcome back. Today we are in front of you with a new tutorial video or new live tutorial video, and today we will be talking about the 8051 basics and its programming in KEIL software. Okay, so I hope many of you have gone through this 8051 programming, and it is being taught in several universities across the world, and specifically if we talk about India, so it is a very basic course which is being taught to engineering graduates in order to understand them the very basic functioning of the microcontrollers and other digital kind of devices. Okay, so let's wait for some time, and let's see if anyone else has joined us. Okay, and if you are joining us right now, so you can comment live on this session so that we can understand you people are enjoying this video. Okay, this live session. Okay, so you can also comment with your city name along with the along with your name as well. Okay. Okay. So please introduce. So I'm waiting. Let's see. So right now there are 5 concurrent viewers. So let's have their views if they are joining us. Please comment on this session in the live chat that is enabled, so that if you have any query, uh, we can try to sort it out. Okay, and after that we will start with our session. So it is going to be a very interesting session, and in this session we will be doing some programming on KEIL software as well, and we will also write the program uh, in uh, in assembly language. Okay, so you will also get to know like what is assembly language here. Okay, so we have this Raju Sharma. Hello Raju. And Nidhi Sharma has also joined us. Okay, you can also type your city name from where you are joining. Okay, so that we can get to know like we are being watched from different connections from so many different places. So what is our reach across the globe, or whether we are being viewed within India. Okay, so we have Rupesh Rajput. That's good. Okay, so with that, yeah, new people will keep joining us, and then you can as well you can keep sending your messages in the chat, and if you have any doubt, you can let us know. We will try to sort it out. Okay, now commenting. Now starting with our basic session, that is the 8051 microcontroller. So first of all, when we talk about in these our live sessions, we will be concerned very less about the theoretical part, and we will be more focusing about the practical aspects. That means how to do program, how to do different kind of that means how to burn the code. So in upcoming session, we will be discussing that as well. Right. So coming back to the microcontroller, so most of you have heard about the microcontrollers, right? Most of you have gone through in the labs in small devices, and like ACs, you have automatic ACs, you have automatic ovens. So all these kind of devices are known as the embedded devices. Embedded devices means where hardware you can program the hardware to function as per your requirement. Okay, so uh, okay, so you can program the hardware as per your requirement. For example, like you can set the different temperatures of the air conditions. So microcontrollers is a very heart of these embedded systems. So these microcontrollers, you can write your program, whatever you need, and in the form of hex file, you can download it inside the microcontroller, and then that microcontroller can control any of your electronic devices like oven, washing machine, AC, fridge, etc. You name any embedded device, you will find a microcontroller there. Okay, so microcontroller in itself are kind of a complete computer. That means they have this RAM, ROM, and program memory, and all the ports, everything within themselves. Okay, so we'll not go through the very basics of like what is the port, what is the RAM. So I hope all of you know about very these basics of this about the microcontrollers. What we'll be focusing more on the critical stuff, or the difficult stuff, which students finds it to grasp or understand. For example, about the memory, about the addressing, how this addressing are used, or what kind of memory, or how to address a memory. All this kind of stuff we will be talking about. Okay, so let's start with the basics. Okay, so when we talk about the microcontroller, first thing I used to say, like, you have to think in digital. Think in digital. So what do I mean by thinking in digital? So whenever you are trying to write a program for any hardware, you must think in digital. That means in zeros and ones only. So zero indicate, that means there is a some voltage is being applied. There is a no voltage. Okay, and one means a voltage has been applied. Okay, so that is the machine language. Okay, so that is very specific. So when if you want to talk about from the hardware perspective, so zero means a ground has been applied there, and one means generally plus 5 volt. Okay, so don't fix it to plus 5, because right now latest controllers are available in the market which can work on plus 3 volt. But that means the voltage is being applied, and for 8051 we treat this plus 5 volt as logic 1. So one means a voltage is applied, that voltage could be plus 1, plus 5, 0.1. So depending on the logic level defined specifically for that microcontroller. Okay, now these are the bits. Now one of the important thing in this bits is the registers, or the memory locations, or I can say the combination of bits. Okay, let's say I combine all these bits, and remember this is just for the representation purpose. So generally this is known as, this collection of bits is known as the register. Okay, so register is again a memory device which have these locations, and on these locations you can store any amount of data. Now there are two different things. These are the memory locations. Inside it you can write 0 and 1 there, and these are the location number. Let's say 0, 1, 2, 3, 4, 5, 6, and then there is another one. Let's put it here. Okay, this is the memory location 7. Okay, so right now I am using the notation, that means the representation of these bits, or the numbers from this location, from right to left. It could be other way around as well, in some different notations, from right to left: 0, 1, 2, 3, 4, 5, 6, and 7. So these indexing could be different for different kind of microcontrollers, and for 8051 microcontroller we use this kind of indexing. That means the rightmost digit is the LSB, it is known as the least significant bit, that is known as 0, and this is the leftmost bit is the MSB. Okay, so this kind of notation we will be using, which is written above. Now this is the location number of the register or the bit, and at any location you can write 1 or 0, 0 or 1, 1, 1, 0 and 1. So the values written in inside these boxes are the values at that location. Okay, so this could be 1, 0. So that means at location 0 voltage is applied, at location 1 there is no voltage, at location 2 there is no voltage, and so on. Okay, so this is the some of the basics, and let's erase this part. Okay, now there could be different things like Yeah, coming to the different notations, these combinations, let's say there are these four combinations, right? So these combinations are known as the nibble. So combination of 4 bits is known as the nibble. So these are lower 4-bit combinations, so it is the lower nibble, and this is the upper 4-bit combination, so is the upper nibble. And IBBLA. Okay. And coming again, the entire combination of these 8 bits is known as the byte. So that indicates this 1 byte is equivalent of 8 bits. That is very straightforward. And okay, now I hope this size of this pen is sufficient for you and you all are able to see it clearly, right? Okay. Moving forward, so this is the very basic of the register. Now we should know about the number systems as well uh, in when we are talking about this digital system. So number system is the representation of numbers. So there is one number system, that is the binary. Okay, so in binary we have only 0 and 1. So anything is represented as a combinations of 0 and 1. And then there is a hexadecimal. There are other as well, decimal, binary, like 4 in decimal case. In decimal number system we represent everything from 0 to 9. Now in hexadecimal we have numbers from 0 to 9, and then we have numbers from A to F. Okay, so 0 to 9 are represented like 9. A is 10, decimal 10 is represented by A, 11 is represented by B, 12 is by C, 13 by D, 14 by E, and 15 by F. So these are the different number systems, hexadecimal number system, and generally this is used because when we have longer addresses, so in this hexadecimal number system that can be represented in a short form. But remember always, these number systems are just for us to understand. Okay, just for us to understand or to represent. Right? If you think like microcontroller is thinking in hexadecimal or microcontroller thinking decimal, that is wrong. Within the microcontroller, within the digital device, everything is being represented in binary form only, and within the binary form only, everything is represented with the help of the voltages only. That means if there is a voltage, that is 1. If there is a no voltage, that is 0. So everything only in the voltage. Even the microcontroller digital system doesn't understand what is 0 and what is 1. This is just for us to understand when we write 0 and 1s. Okay, so now converting numbers. So coming to our register example. Okay, so let's say we have this 0 1 2 3 4 5 6 7. Okay, 0 1 2 3 4 5 6 and 7. And the again, this is the locations, right? And we have this 1 1 0 1 0 1 0. Okay. So if we want, right now it is represented in binary form. So if we write it in binary form in any number, so we will write like 0b 0 1 0 1 0 1 1 1. So it will consume lot of space. Okay, if we try to write in hexadecimal, so we can create a combination of 4 bits, right? Okay, that is a very short one. So this is 0 1 1 1. Okay, so what is the decimal equivalent of this 0 1 1? 0 1 1 1. So the decimal equivalent of this is, so it is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, and them all them together, multiply them. Okay, 1, so 2 plus 2 plus 4 plus 2, so it is 0 plus 4 plus 2 plus 1. So it comes out to be 7. So this is 7, and this is again, if we go by this logic, 5. Okay, let's see. 4 1 5. Okay, this is 5, this is 7. Okay, so hexadecimal represented 0 x 5 7. Similarly, let's say if we have number 1010 and 1011, so this is 10, decimal is 10, and in hexadecimal we represent 10 as a, and this is 8 to 10 11, and 11 is represented by b. So this number in hexadecimal form will be represented as 0x a b. Okay, okay, so I hope that is that is interesting, right? And it will be easier to understand. Okay, so this was the very basic about understanding the uh, number system which is available within the which we will be using throughout the programming part. Okay, and you should know about it. Now coming to the microcontroller. So as I said, microcontroller is okay. Prior to microcontroller, let's talk about some others as well, like what is the data bus. Okay, okay, okay. Prior to data bus, I should be talking about what exactly is the bus is. Okay, so now think about from the perspective of a wire. Ultimately, the data or anything which we want to transmit from one place to another place, we need a wire. Now if we have a single wire, right, so this single wire can have only two states, either 0 or 1. So if we apply 0 here, at this location we will get 0. If we apply 1 here, we will get 1 here. So only this single wire can carry only these two bit of information, right? Now let's say if I increase the number of wires, okay, let's fix it if possible. Okay, okay, let's spin it. That will be better. Okay, so let's say if now if we increase the number of wire 2, so now there are two wires. So each wire can carry two different information. 1 0, this carry 0, this carry 1, and so on. So now there are two wires, and total information they can carry is 2 to the power 2, because one wire can contain two information. Now there are two wires, so this can carry two information, this can also carry two. So total information which can be carried is 4. That means 4 different bits of information can be carried. Similarly, if we take it to 3 wires, now it would become 8. Total information that can be carried by these wires will become 8, right, by these 3 combinations. That means 3 different representation of bits can be carried by these 3 wires. Okay, that means by increasing these lines, it keeps on increasing by the order of 2 to the power n. Okay, where n is the number of wires. So if there is 1, it is 2. If there are 2, it is 4. If there are 3, it is 8. So keep this in mind. Now this is a wire. Now what is bus is? So bus is nothing but just a collection of wires. That means collection of wires. So that means if we club all these wires together and make a bundle of this wire, it will become a bus. Okay, now it is understood to you. Now coming to what exactly is the data bus in that case, right? So now talking about this data bus. Now data, anything is a data, right? But from our perspective, the information which is written in this register, okay, 0 1 2 3 4 5 6 and then 7. So we want all this data, because this 1 1 0 1 0 0 1 1, this is the data and this is the location number only. we want to transmit this entire data from, let's say, A location to B location. Okay, now they are 8 bits. Okay, and just here we came to know, okay, one wire can transmit only one bit, right? So that means we need the collection of wires. And how many collection? The 8 number of wires in this case, if we want to transmit this entire logic. That means this bus which will be carrying this data information, that will be known as the data bus. Okay, and what will be the size of this data bus? 8 bit. Okay, so this size of the data bus is of 8 bit, because this bus can carry at a time 8 bit of information, and this decides the size of the microcontroller as well. Size of microcontroller, that means we say, okay, it is a 8-bit microcontroller, or it is a 16-bit microcontroller, or it is a 32-bit microcontroller. So 8-bit microcontroller means it can carry 8 bit of information as a data bus. So its data bus is of 8-bit length. If we can say 16-bit microcontroller, that means its data bus is of 16 bits. That means there are 16-bit 16 different wires clubbed together to form a data bus. Okay, now there's a one more bus you may have been encountered largely during your course, that is address bus. Okay, now here we were talking about the data to be being transferred from one place to another place, and that bus which is doing this specific operation, that is the data bus. Now in the address bus, what happens? We have a memory, right? Like your homes are aligned in your locality. Similarly, within a memory there are locations. Okay, so this is the memory structure and these are the locations. Now each locations is divided into 8 bits, because we have a 8 bit of memory. That means 0 1 2 3 and up to 7. Let's say it is divided into the memory, and all these registers or all these memories are stacked together. Okay, now there are two things. Each location, so this is the 1 8-bit slot. Okay, this is second 8 bits. Okay, now within this memory at this location we can store 8 bits. Now this is the second location, we can store again second bits, and so on. So now there are two things. Horizontally, that means the column wise, so column wise the bit information, and then the rows, and rows contains the number of memory spaces available to us. Okay, so let's say it is 0 number, we assign it 0, we assign it 1 2 3 and up to, let's say, n number, or capital M number. Okay, now if we have a single wire, it can contain either 0 or 1. So if it contains 0, it will access this location. If we apply 1 here, it can access this location. Very straightforward. Because there's a, if you have gone through the digital electronics course, you may have there's a decoder circuitry in between, but right now we are just for the sake of understanding, we are writing it directly. Okay, now there is a 1, we can access this location. Now let's 2, so 2 cannot be represented, so in order to 2 we have to write like 1 and 0. So for this we need 2 wires. So if we have 2 wires, then we can access this location, this location, this location by writing 1 0, and then this location by writing 3. So all these numbers are in hexadecimal format, or ultimately in binary format as well. Okay, so the more number of wires are there, and the more number of location we can access, right? If we have 3 wires, we can access up to 2 to the power 3 different values can be passed, 2 to the power 3, and based on that we can access total 8 different locations. And similarly, if we keep on increasing, so if there are n number of wires, so we can access 2 to the power n different locations of the memory. So now these wires are used for the address purpose, right? Address of what? Address of the memory. So address of 0, 1, 2, 3. So these are the memory locations. So we want, these are the address. So these wires are being used to addressing of the memory. Okay, so that is why the bundle of these wires, if we club this together, it will form a bus, and this is known as the address bus. Okay, so these are two different things, data bus and the address. So data bus is used to transfer data from one location to another location, and then we have this address bus which transfers data from, again, from one location, which don't transfer data, which tries to access the data which is being stored and at any specific location. Okay, so this bus is used to decode the address or to fetch the data from those specific addresses. Okay, so these are some of the basics of the microcontroller, and which will be handy during the entire operation. Okay, so now we will be jumping to the programming part. Okay, so uh, if we talk about this are okay, we will be talking about this RAM locations and available RAM in the microcontroller in our next session, next online session. Okay, because we want to keep this online session up to 40 minutes or the 35 minutes, so that you don't get bored while attending the class. Okay, okay, let's type good morning everyone. Okay, now we will jump to the introduction of KEIL. So in this entire online session, we will be using this KEIL software. Okay, so you can download it, the KEIL. You can download the KEIL software from the official websites, and there is a free version which can compile the data up to 2 kilobytes, right? 2 kilobytes of memory size. Okay. Now we will be having some basics of the KEIL. That means how to build a program in KEIL and how to write a small code in KEIL. Okay. So we will be jumping to the KEIL now. So let's jump to the KEIL and add it to here. Here it is. Okay. So I have written a different program right now. Okay. So we are jumping to the KEIL now. So in this KEIL, as I said, you can download it from the official website. Uh, you just type KEIL software, and Google will give you a link there. So we will understand how to create a very basic program in the KEIL. Okay, so you have to go to the project. So in project, click on this new microvision project, and within this new microvision project, now you have to create some location frame at which you want to store your all the programs. Okay, so we will create a new folder. We'll type like online codes or online tutorials. Okay, within this is our first code, right? So we'll type 0 test. So 0 indicating our lecture and the code number. So we are testing it. So within that folder, because if you don't create folder, it generates a lots of file, and that it will be very hosh posh around. Okay, so I will suggest to create a folder and store all of your files into that folder only. Otherwise it will be very messy, right? Okay, now we'll type the code, test, save. It will ask for the microcontroller, so we'll be writing the code for 89S51 microcontroller. So there are a lot of microcontrollers are available from lot of manufacturers, and you will also think like this 8051 were introduced in 1980s, and still they are being used in the industry and in academics because due to their simplicity in programming, and a lot of changes have been made by the different microcontroller manufacturers, so that this 8051 now coming up nowadays has more number of functionalities in it with more power. Okay, so That is being used still in recent times as well. Okay, so 88 okay, yes. Now here we will create options. Okay, so you can go to options. Not now, you first add new source file and add this asm source file, right? And asm source file means assembly source file, so we're writing a code in the assembly languages. So we will write a very basic program. Okay, so main underscore asm and then add. Okay, the file will be added here. Now you can go to the options. Now in the target you can set the frequencies. So generally 11.0592 megahertz frequency is being used typically, and then is the device, and then output we can create hex file. So if you want to download this hex file onto your real hardware, then we have to create this hex file. So in this entire online tutorials, we will be using this Proteus simulation software in order to simulate the real hardware, real time. Okay, and then okay, our code is written. No, let's write. So I will suggest to open this with org. So our hex code is written with this org 00h. So it indicates like we are writing our code from the 0th location of the code memory. Okay, so okay, we will talk about this code memory and RAM in the next class, but there are two different kind of memories available within the microcontroller. That is the code memory and the data memory. So code memory is the memory in which whatever we write the code that goes into it, right? Like a flash, or generally that is also known as a program memory as well. So that goes into the flash memory of the micro. And then there's a RAM. So RAM is the thing, as you know, during the execution of program, several different variables will be created. Those variables will be stored in the RAM of this micro. So here writing 00h means so because when microcontroller got reset, so it starts from 00 location of the memory. Okay. Okay, so coming back to the next line, so we will type like move. So these are some of the basic commands. So right now you don't have to understand it much, like 35h. So this is the kind of code we'll writing it. So in accumulator we type 10h, and then we add these two numbers a comma r1. Okay, and then we move this addition to move a r2 comma a. Okay, and then we will create a label here, and we will type sjmp here. Okay, so it will keep on jumping here other because it is a kind of an infinite loop in C language. Okay, so what will happen if we don't put this sjmp command? It will execute the end command and come out of the execution part. Okay. Okay, so now let's compile it. You have to click here. It will rebuild the entire code, and if there is no error, it will give 0 error. And in order to execute run, you can go to debug. So debug, start and stop debugging session. Okay, now from here you can run the code one line at a time. So first line is executed. Here you can see different register. These are the RAM registers. Register 1 25, accumulator 10 has been assigned. Now the addition, remember these are the hexadecimal code. Okay, so don't get if these are the decimals number. Okay, 25 hexadecimal is not equal to 25 decimal number. Okay, so these are two different things. So 10h indicates it is a 16, not 16. Yeah, no. It is a 0x0110. Yes, it is a 16. Yes. And now addition is 35, and we are now moving this addition into R2. So here R2 again 35, and then it will remain here. Now here's the memory window. You can also see the memories. Okay, so if you see it, see for the code memory. So here this is the hexadecimal code of hexadecimal hex code of this program. Okay, So hex code means each instruction has a corresponding code, fixed code, that is defined by the manufacturer. Okay, and it is true for either you go for Pentium processor or anything. Hex, ultimately hex codes are there which is being run by this computer. Okay, so these are some information in the bits, again bytes form. Okay, so this is the hexadecimal hex file or hex code of it. And if you want to know the data memory of it, you can simply write like D and colon and then enter. So this is the data memory. So it is the R0 R1. So remember, in R1 we passed 25, then in R2 we passed accumulator. Similarly, we have some fixed function of accumulator that can also be found here as well. Yeah, yeah, this is the address of that. So we will understand all these values in upcoming classes and upcoming live sessions as well. So please remain with us in the future classes as well. So I hope we talked about a lot today, and we talked about how to use this KEIL software and what are the very basics of this 8051 microcontroller and very basics of the microcontroller, I should say. Okay, so in our next upcoming live session, we will be talking more about the microcontroller. Okay, so that's it for today's live session, and we will end up. So we will stop some time for providing some answers to your queries. So if any one of you have some queries, you can let us know by commenting or by typing your queries through this live chat session. I am available, so you can let me know. And if you have any query, then I will try to solve it. Right. So basically, there is a delay. Okay. So if any one of you you can ask anything. So let's wait some time. Okay, there are no queries for today, so we will end our session here, and then we will be live again in very short within upcoming days. Okay, or that will be next week. Within the next week, we will be live again. Okay, so till then, stay safe and keep learning.